Okay, we're looking at exercise set 1.3.3, Physics 11, question 9. Stone is dropped from the roof of a high building. Second stone is dropped a second later. How far apart are these stones when the second one's reached a speed of 23 meters per second? Okay, so everything's falling downwards, so let's pick down as positive. Positive. And we need to look at two scenarios. We've got to look at stone 1 and stone 2. Okay, so VI, stone 1, 0. VI, stone 2, it's also 0. Oh, brain fart. 0. Okay, acceleration, 9.81 meters per second squared. Acceleration here, same. Second squared. Okay, now the time. This is where we get some wonky time. So we can say the time for stone 1 is the same as the time for stone 2 plus 1 second. Right? That's 1 second longer. I want to know the displacement of 1. That's the question. Stone 2, we have some other information. We know velocity final over here at 23 meters per second. T2, we don't know. Displacement 2, we don't know. Okay, so let's get this thing kind of shrunk up a bit. So let's shrink this. Let's get him level again, but shrink him too. So shrink him down and move him over here. Shrink him down, move him over here. Okay. Okay. Back to work. Change color. So let's see. We know more about stone 2 than stone 1. So let's start with that object. See if we can find displacement and time. Okay, so let's look at stone 2. Okay, so we use our acceleration formula as VF minus VI over T. We can solve for T. 9.81 equals VF, which is 23, minus 0 all over T. I get 9.81 T equals 23. T equals 23 divided by 9.81. Bring that up here. T equals 2.35 seconds. 35 seconds. That's T1. T2. T2. Okay, we want that. Now, D2. Displacement, we can use the VF squared formula. So D2 is VF squared minus VI squared all over 2A, which equals 23 squared minus 0 all over 2 times 9.8, which equals 23 squared over 19.6 T squared. Okay. Let's shrink this guy down. Move it over here, a little smaller. Okay. solve. See this over here then, say okay, displacement d2 is equal to 27 meters. Okay. Okay. Stone 1. We get T1 now, because T1 equals T2 plus 1. So T1 equals T2, which was 2.35 seconds. Here it is right there. 25 seconds plus 1. For those that need a calculator, go for it. T1 goes 3.35 seconds. So now that we have our time, I think we can find our displacement right quick. And with a T, so displacement 1 is VI T plus half AT squared. VI I believe is 0, so this thing goes to 0. So I'm left with D1 equals 1/2 AT squared, which equals 1/2 times 9.81 times 3.35 squared. Let's shrink this down now so I can get the rest of this in. There. So delta D1 is 55 meters. So there's our two numbers. This one and I don't know, I think it's that one. This one. Alright. Let's do a different color just for fun. I can say that the total, the difference between the two, so the difference between the two we'll call X, is delta T1 minus delta T2. So X equals 55 minus 27. X equals 28 meters. Question is complete. So you can say, therefore, after when the second stone has reached a velocity of 23 meters per second, the two stones are 28 meters apart, falling